In this video, we're going to briefly take a look at the perpendicular bisector theorem, and we're going to do a couple of problems related to it. So let's go ahead and discuss the perpendicular bisector theorem. Perpendicular bisector theorem. And the perpendicular bisector theorem states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, so let's illustrate this in this drawing here. Let's say we have a line segment, and it is AB, and then let's say we have a perpendicular bisector to the line segment, which intersects AB at point C. So what do we know then? If this is perpendicular, I've already written a right angle symbol here, so you know that all the angles at the intersection point at C are right angles. And because it's a bisector, you also know that the measure of AC equals the measure of CB. So by notation, we can say all of that. And then the theorem says that if you take any point on this perpendicular bisector, let's call it point D, then that point will be equidistant from the endpoints of the segment, which means that D is equidistant from A and B, which is the same thing as saying as AD is congruent to DB. So how do we know that this theorem is true? Well, we know that AC equals CB because it's a bisector. We know we have a right angle. And we know DC is congruent to itself. So we actually have the congruent statement that triangle CAD is congruent to triangle CBD because of side angle side. Okay, and that's because AC is congruent to CB. This is our side. All right angles are equal, so DCB, which is this right angle here, is going to be congruent to the right angle that is at DCA. So we have an angle, and then DC is congruent to itself. So we have side angle side, we have the two triangles are congruent, but then why does it follow that AD is congruent to DB? So then we know that AD is congruent to DB because of corresponding parts of congruent triangles are congruent. Okay, so since AD is opposite the right angle in the left triangle, and DB is opposite the right angle in the right triangle, and therefore AD corresponds to DB, their corresponding sides, since we know the two triangles are congruent, we know that corresponding parts of those triangles are congruent, so we can basically determine that AD is congruent to DB. So I've avoided actually writing out the formal two-column proof here, but you should do that on your own. In other words, you should feel comfortable to write out a two-column proof on your own so that you are totally convinced and you are prepared to be able to prove this if you ever needed to.